Hi guys, welcome to this session on smart logistics. Some people may call logistics 4.0 as well. If I had to say in a simple word, it is nothing but optimizing the logistics chain intelligently. We have all heard about supply chain. So here I'm trying to call logistics chain. And the word intelligently means we are trying to use not in a mechanical way, but we're trying to collect the data, analyze the data, and make decisions through artificial intelligence as well. So we'll be talking about all those technologies when we talk of smart logistics. So keep in mind that when the word comes smart, whether it's a smartphone, smart supply chain, smart factories, it means we are using digitalization as a base. Now the learning objectives for today, what we have kept up is understanding what is the next gen logistics around, which we may call smart logistics. So what is the next gen? The next is understanding logistics 4.0 and industry 4.0, because when we say logistics 4.0, which Americans call as smart logistics, is nothing but it is in the context of industry 4.0. So what is the vision of industry 4.0 as per World Economic Forum? We'll walk through that. Then the word which is used very often is that I'm digitizing my activities around. Then somebody will say, no, I'm digitalizing it. There's a vast difference between the two terms around. So this is where we like to talk about it. The next one we'll talk about is, okay, we're doing digitalizing, but is there a framework? Because there are so many software, there are so many subsets. How are they integrated? I've got a warehouse system, I've got an inventory system, I've got a manufacturing execution systems. How are they integrated around? We'll talk of the framework. Next, we'll talk about the traditional logistics supply chain, which is more of a straight line. One activity moves to the next one, then to the next one. So by the time it goes to the last, it's too late. While the other one is called supply chain control tower, some people call even the circular logistics a circular supply chain, but it's easy to understand if I use the word control tower. Then which are the technologies enabling the change in the logistics? So when we talk of logistics, which are the technologies which are going to make it smart logistics? The future of logistics. And lastly, it's easy to say smart, but the question is, what are the challenges? Obviously, the first challenge is always the people. So what are the challenges about? So including the practices, including the procedures. So those challenges we'll talk about. So broadly, I would say the key objective from the today's is to optimize the logistics chain intelligently. That's what we are trying to do. Let's first understand the very basic fundamentals. What is logistics? You ask different people, even in the books around, some mix up in some of the workshop I've been around. The name of the workshop would be supply chain, while they will be talking of logistics. So there's a big confusion about the term logistics. Some consider as a transportation activity. And I would say in India, at least 70 to 80% of the logistic is under the unorganized sector. Most of them are transporters. While others call it a supply chain. Obviously, it's linked to supply chain. There's no second thought. It's part of the supply chain. So it is called supply chain. So broadly, if I had to say, it is about the flow of goods and information, because information also goes. If I'm coming from one ex-supplier, he's a foreign supplier, there's a bill of lading, then the information also flows. The country of origins and everything comes up in that. So broadly, if I look around logistics, there are three components: transportation, distribution, and port export. So broadly, logistics has got these three pillars. And all these three pillars have got planning as one dimension, and execution is another dimension. So transportation, we all know very well. I have to think of supply, shipment optimization, I have to think of carrier contracting. Then execution part is the selection part. Shipment tracking is another one. Freight payment is another one. In distributions, obviously, then you have facility design, you've got a warehouse, you've got inventory management, all those things comes up there. And the next one is export and import, where we're talking of custom clearance, freight forwarding, all those activities. So you can imagine around the logistics cover wide range of activities around. So if I say the chain, and once you understand what is logistics, it's a broader term. So it is not just the transportation. It covers packaging, it covers warehousing, it covers the inventory management, it covers all those things, including the distribution part. So if we talk of the chain, so far we all heard about supply chain. And you all know very well supply chain connects end-to-end all the organizations, all the activities, all the individuals which are required from one end to another, end-to-end. Well, logistic chain also follows that to a lot extent. It also follows from the source of raw material till the customer, if you look at the bigger chain. So it is a path of goods and information. Keep in mind information also, because the information goes along with those documentation, whatever your shipment documentation, they go along with that from the point of origin to the point of consumption. Consumption is my final customer. So the activity which are required in the logistic is planning, because without any activity, whether it's a procurement or anything, you need to plan first. Transportation, warehousing, packaging, handling, distribution, and security. Particularly when they're coming from offshore places around, security becomes very important around. Now, it can have tangible and intangible goods and services. Services also are in the logistics. So that is also part of it. Is not only the tangible part which I can see physically, intangible goods also there. Services also there. Now, lastly, when I'm trying to summarize this, logistics can be defined as the art of managing the supply chain, because it follows to some extent logistics, supply chain. So art of managing the supply chain, and it's also a science of managing and controlling the flow of goods and information and optimization. So that way it covers the both part. There's a science component, there's an arts component. Look at this chain. So one side I got raw material, other side I got a customer. So the raw material has to be moved to the supplier. Supplier moves to the contract manufacturers, from contract manufacturer to the main OEMs, from OEMs to distributors, from distributors to stores. So you can imagine around all over the through. Here I have shown more with the air shipment, but it could be any mode of transportation from one end to another end. So transportation, logistic is required around. This shows a little better way, starting from supplier to customer. So you have producers. The goods have to move from supplier to this along with documentations. Then from producer to distributors, again documentations, informations. In supply chain, you've got three things around. If you all know the definitions, there's a flow of goods, there's a flow of information, and there's a flow of funds also. Here, we are only talking of goods and information. So we have producer to distributor, then we have got third-party logistics, retailers, store, customers. And underneath I have shown what activities gets involved. So there is an information and activities. And if I go with a modernized system, what many companies have got around ERP system. So in ERP, you've got a warehouse management system. You've got manufacturing execution system. Again, warehouse management system. So from one end to another end, you can see the transportation is shown around. So that means goods are received, again through the transportation, through the, again, logistic part. Warehousing, again, logistics part. Again, you have to transport. Goes work in progress, is again part of logistics. Production, work in progress. And once the goods are finished, we transport them to the warehouse, ship them. So even within this mechanism of today's, this is the chain it looks like. Let's go back a few things around about India, how India is looking as the logistics side. Today, if I look around only in the transportation logistics sectors, India employs around 7.3 million people. And we expect this number to be 22 million by 2022. All of you are seeing around the GDP might not be growing that much, but logistic part is growing faster. If I look at the, again, logistic companies will need to find more than these people in the next 10 years. The type of people we need logistics. We need people who are technologically savvy, who can understand about robotic process automation, who can understand about the big data. You need different type of skills. Who can do the demand management. So this is the enormous challenge which we have today to get the right skill as well. If I look at the size of industry for India, in 2014, it was only 110 billions. Already we are crossing around $200 billion in the last 5 years. Now let's try to compare India's context with China and US. If I look at the logistic cost, as percentage of GDP, India is around 13%. All developed countries are close to 8.5. The reason could be one is very clear, everybody understands is infrastructure. Then there were a lot of speed breakers also. Speed breaker being the rules from one state to another state, which have been simplified in India now. But still we are on the higher side. That means there's an inadequate, one is the road still around. Second, I think the skill is also a problem around. So this is the area where there's big potential for growth around. That's where we look at it. If you look at the share of logistic costs for different type of sectors, cements, 15%, auto is the less. Maybe the auto side is very well organized, more systematized. Logistic cost, if you divide into the 4 components, transportation is 40%. Warehousing is 26%. Inventory part is 24%. Order, this is the norm. So if I can cut down the warehousing part, inventory to the less, like yesterday I was talking to one company, the pharma company, their inventory level is touching around 90 days. If I can cut from 90 days to 30 days or 21 days, you can imagine the 26% could become 8 or 9%. So there's a big potential. On top of it, transportation, today if I look around 70% is through the roads. If we can use rail or we can use sea, the cost could be brought down. So there's a big potential of saving from that angle also. The share of 3PL. 3PL makes a big difference. I'm an auto company. My focus is on making good cars. Now, if I'm going to take care of transportation, I'm not specialized on that part. So this is where the focus is becoming to have your niche area. Specialize in your own areas. Wherever you're not good, give it to third parties around. So third party logistics, India is still very small, 9%. Japan is the highest, 80%. US is 66, 57%. Europe is around 40%. If I look at the logistic chain again of India, it is still a silo work. The warehousing works in its own way, transportation is another way, the packaging is another way, so it's all discrete siloed steps. One guy does not know the other end. So, but over the last 10 years, the big change has happened. If you look at even the ecosystem, there's a lot of new technologies have come up around. Obviously, the big data is there. Robots are there for handling purpose. Then IoT is there around. And so this is where I can say the change is enormous. Let's understand now, when we're talking of digitalization, where does it start from? It all starts from Industrial Revolution 4. Here I've got little doubt on the revolution part because Industry 1 was a revolution. It happened in 18th century when the steam engines were done. So we all know steam engine means we could mechanize it. So something which I was doing manually, then I could mechanize it. So obviously the steam power helped me to make mechanical production. Then we had the 19th centuries, electricity. So the electricity helped us. The Ford was the first one to come with the belt conveyors. So we could automate the production. We could move systematically. Then came the 20th century from 1969. we went down to Industry 3.0. So it's basically industrial revolution, third revolution. Computers came, people started talking about digitization, not digitalization, digitization. People started about the networking. So if you look around Industry 1, there was an innovation of steam. Industry 2, there was an innovation of electricity. Industry 3 was also innovation of computers. Industry 4 is not the innovation per se. So I would call as an evolution 4. But in normal words, we always say it's Industrial Revolution 4. But it's an evolution because internet was available, computers were available, a lot of technologies came up around. Now we are able to connect all those technologies through the internet, particularly through clouds. So once we're able to connect, so it became more of a connected system. The man and machine could be connected, machine to machine could be connected. So in the process, we become very well connected. So that is where the whole benefit is coming around. We were doing earlier Industrial Revolution 3, developing some robots, developing this. Now robots can speak with the machines. Robots can also work as an assistant for us. So that's the advantage we're trying to take of internet here. So internet is becoming a connecting point around. As you know, in our day-to-day life, we're all digitally connected. So Industry 4.0 is broadly, the concept came from the Germans. I mean, obviously in their countries, they're moving very fast into technology part. Population is going down. They want to move. So they said, okay, we want to industrialize to the next level. But the world cannot be left behind when you have to compete with them. So this is where the whole thing came up around. In short, they said the use of CPS, cyber physical system. That means integration of computation, networking through the internet, and physical processes. So whatever processes I was doing earlier, let's say with the Excel spreadsheet, I'll collect the data. I will have an Excel spreadsheet. I will analyze it. It will take me 2 to 3 days. Now those data, which could be trillion of data, if I'm working on a global basis, I've got trillion of data, integrating them, analyzing them, which become my big data. It could take me ages. So that is what we're talking of CPS concepts coming around. And that is what is Industry 4.0. So when we talk of Industry 4.0, industry mean I'm talking a broad sense. A factory could be one part of it. Supply chain is another part of it. So if you take around Industry 4.0, you need a digital supply chain, smart manufacturing. You need product also digital. That means I should have a CAD, and from the CAD I should be able to make the CAM and get the products in. Data analytics. I'm still remembering the days when I started implementing this CAD and CAM. In India, it was in the year 1985-86. I happened to buy the stuff from Japan, and then we developed India also. So this is becoming very important around. Data analytics. Now this is how the Industry 4.0, if you look around in the bigger picture, suppliers, logistics, physical productions. So physical production, you can see the person and the robots working together. Virtual productions and digital productions, and there are sensors, all are connected to the clouds. So any information, anybody can have it anytime, if you allow them. So that's the way it is going to work around. It's a very connected system. That means all the players, the whole ecosystem, whole stakeholders, all are connected. So if I'm a supplier, I know very well this time the production is going to go up. Next time will be next week, the plan is this month. Accordingly, I can plan my production. Now the technologies which I call, which are relevant to the Industry 4.0, the 9 pillars they talk about. First thing is autonomous robots. Already in the auto industry, we're using quite a lot of robots. It's the building of the cars. So when I say robot, is a physical things which is programmed to do particular activity. That's a robot. In the robot, you can put artificial intelligence also, if you want them to think further. But if you want to say, okay, this is the function you will be doing, you'll be moving the goods from this place to the belt conveyor. You could have autonomous robots. System integration. I might be having many systems. Now I have to connect them. I've got 100 plants. I want to connect the various systems around. So those systems integration, I will be touching on the framework. Internet of Things, that is the first thing I would lift from the logistics side. The key for making it, I would say, is smart logistics around. Internet of Things, IoT. So keep in mind, I'll be using this word IoT very often. Simulate something. I know these type of problems happens, I can simulate them. Additive manufacturing. 3D printer, everybody knows about it. Some people in India have already started using it to get the spare parts for airline and this. Additive manufacturing, 3D printer. Cloud computing, I think all of you know nowadays. Again, one company was telling me around that they had 90 people working with them on servers. Now they're moving into the clouds. So that's a concept that's coming around, augmented reality. Particularly my warehouse is big, more than 100,000 square feet. So when I say more than a lakh of square feet, if I have to go from one end to another end by transport, then I can augment my reality around. With those tools, I can find where is the things lying around. I can save my time. Big data. The data is big, trillions of transactions around. How do I check them? How do I analyze them? My existing systems are not capable. So that's what we're calling as the big data. Cybersecurity. This is becoming a critical issue. The more we get digitized, so the digitized still leads to the central system. All the data are going to the central place, one place. And anybody can hack it. So this is the very basic concern of cyber. But this is where now the next stage is coming around in the blockchain. So the blockchain has also become one of the pillars of Industry 4.0. So once we get into the blockchain, which moves from central to decentralized system. So the chances of getting into hacking, disturbing it is impossible to a large extent. So now let's understand the digital supply chain. Digital supply chain is one component of Industry 4.0. So within supply chain, if you look at the vertical component, logistic is one of them. Warehouse is there. So we expect the procurement to be 4.0. Or if you want to say in a simple word, you can say smart procurement, smart logistics. The Europeans came with the word of 4.0, while Americans use the word smart. You have a smartphone, smart this. So smart means it is basically digitalized. So you could call it as equivalent same terminology. So this is again shows the supply chain with three components: sourcing part, manufacturing, and logistics part. And obviously the planning also has to be done digitally. That means you are connected with the customers. If customer demands are going up and down anytime, that data is coming to you. So that means your demand planning is to the real time. It's not the demand planning that you do in the years before and then you find when you start manufacturing, the demand has gone down. So evolution of logistics 4.2, if you look in the last segments, we're talking of the big data, we're talking of the blockchain, we're talking of IoT. So those are becoming very crucial when we talk of evolution part. Now the digital journey, if you talk about India, the word is everywhere around. Everybody talks of digital. The government of India has also launched Digital India. And we from ISM-INDIA are working very closely with them on a big project, is to codify the goods and services by using UNSPSA. Because today they spend money on different goods and services, but if somebody has to analyze the data, it's quite complex because without the proper coding system. So we are doing, our 2 or 3 people are full-time involved with them on this project. Now some people think that, guys, why should I get into digital? First thing, they are scared that somebody will take away my data. Obviously it brings transparencies. Some people don't want to be transparent. But then some people think it's a sinkhole. If I spend money on technology, whether I'll get a return or not. So you've got 2 choices. If you want to go on the ladder up, You have no choice. The word is, you know very well, the industry is becoming very uncertain, very competitive. You have to be different than others. You think of any business, even our business, what we are doing around, we have to be different than others. If you're not different than others, difficult to survive today. So you have to, this is how I look around the digital journey. There's no way, we have no choice around, and this is a game changer tool for us. So here again, I want to explain the two terms, digitization, digitalization. The third is transformation. So when I talk of digitization, a simple example I can tell you, I remember some time back, I went to one of the country office. So I was in Philippines. I saw one guy, a qualified graduate, sitting with a pile of papers. I said, what are you doing? He says, morning till evening, the guy was putting on the machine, scanning it, storing it. So when I said, what are you doing? Oh, sir, we are trying to digitize our activities. Sounds okay. I'm not doubting it. It is digitizing. So basically converting the documents, or you could say analog paper, into digital. But don't think it's very, very unproductive. So there's a need to have something which is native digital. So it should come automatically digital. Not that somebody has to get the first hard copy, then from hard copy and make a soft copy. It's a duplication of work around. So digitalization means it's a native form, is going as a digital. If I'm sending to the supplier my invoice, I'm sending to my client invoice, then the invoice goes straight online. I don't have to give them the hard copy and then they scan it and upload it. So it has to be my native system. Actually, in that sense, the blockchain is the best because everything is very native. And the last is, my function I have done in the warehousing, let's say digitalize. Transportation has not done it. Finance has not done it. But ultimately, all are connected together. So when we say of transformation, we're talking of the whole chain, not particular function. Yes, we'll be doing it first by function, but transformation means that end-to-end, organization takes the lead, guys, we're going to transform. That means we're going to be digitalizing ourselves from end-to-end. So if I talk about the logistic from one end to the end of the customers, all activities, all movements, all storages are digitalized, totally online. If you look at the digital competitiveness part, India ranks around under the 3 parameters. The knowledge-wise, we are 36.7. But when it comes to the technology side, we are 59. The reason is very obvious. Very few people want to invest in technologies. And when we talk of the future readiness, we are 51. That means we still have to train a lot of people in this field. Maturity-wise, you can see there are majority emerging leaders and established leaders. Very few percentage, 8 or 10%, who are established leaders. So if you look at the maturity from the digitalization, there's still a long way to go. Now, when we talk about evolution of logistics, as I said to you, start from 1, 2, 3, 4. Now, many of you may be still in the 1 stage, some of you will be in 2 stage, some will be 3 stage, 4. If my client is connected, look at even our own home. Many of us, the young people, are getting used to buying online. They feel comfortable. So when my client is also digitally connected, I have no choice. I have to get digitally connected. So that's the way we look at it. Everybody, even the client, should be able to know where is my goods are, when they are coming. So that's the way we do. And if my goods are coming, particularly the medical item or food item, I want to know the temperature. I want to know the humidity. So all the factors, they can check it around. The key technology, if I look around from the logistic context, although there are 9, but the broadly are sensors, IoTs, robotics, big data, artificial intelligence, they are the broad around. So if you see this one, the key technologies, I'll try to give you analogy with the human body. IoT plus AI plus RPA is equal to the future of digital. IoT is Internet of Things. So most of the objects, today around 9 billion objects are connected. And the number is growing with a very fast speed. Then we have artificial intelligence. Then we have robotic process automation. Combine three things together become the future of this. Now here I've tried to show IoT. IoT, if I look from the human side, because the God has created us with all these things around. We have eyes, we have ears. Eyes don't, if I look at someone, I say so and so is so and so. Who answers it? Eye passes on the current to the database, goes to the brain. So from the database, the brain tells this is so and so person. So you can imagine around, so there are information going from our ears and eyes. If some sound I come to me, I can understand. So who ultimately decides is the brain. And this goes in a very quick, the real-time basis. So this is the whole IoT is nothing but more or less equivalent to eyes and ear. Then that information is going to the brain, where the same thing is here. You can see in the picture, more like artificial intelligence. It analyzes it. And then once the brain says, guys, you have to move your hand, the limb moves. And this is where the automation comes in. If I'm having my goods to come from one end to another end, I've got an automated vehicle in my warehouse. So AI will tell them, guys, pick up this material and bring it to this place. It could work in autonomous spaces. So that means RPA can help you to do many things of autonomous. So even many of the big companies, particularly even Amazon, particularly the e-commerce business, they're doing a lot of movements to the belt conveyors through the robots. So this is where the combination can help you a lot to understand what is digital. So analogy, the way I was giving you explanation, the biggest machine, we are the one human being. We use our eyes and ears and other to sense what is around us. Then our brain is basically, the mind is to analyze and make detection. But if one of them is not working, we could get crippled. Same story happens. You need IoT, you need AI, and if you want RPA, a combination can do a very well job. So here again, I've tried to explain the IoT is nothing but the more like eyes and ears. The data part is the big data is our brain. We have the data also, quite a big one there around. The power of IoT. So if we are trying to compare with the analogy with the human being, with eyes and ears, so IoT enables the enterprise to hear from its goods and assets. I have my goods and assets worldwide. And all assets are connected with RFID codes, and they are connected with sensors. They have IoT. So all my goods and assets are connected. Where they're traveling, where they're moving, all information is coming around. So the drawback, if I look from the IoT side, IoT is connected. All informations are coming. But keep in mind, IoT does not have a brain of its own, doesn't have a mind of its own. So that is where the AI helps us to analyze that data. So in short, you have got, let's say, 20 shipments are going around. You've got 40 warehouses. All that information are connected through IoTs. That information is coming to you, but that information is only data. And that data has to be analyzed. And that analyzing means you need the AI part. And this is where the AI chips in. So AI is nothing but intelligence exhibited by non-human entity. Obviously, humans all have got intelligence. Here I'm talking of the non-human intelligence. But these are basically done through the programming part. So it's basically a machine mind. Now, some people will think, why do we need AI? I think there's a limitation from the human side. Suppose if I have to do something 10,000 times a day, I'll get bored. I can do 1 time, 2 times, then I get bored around. So those activities which are repetitive, those activities which are mundane, which are repetitive, they can be done with the help of artificial intelligence. So this is where advantage. Sometimes there's a hazard also around. So in those cases, it hazardous where there's a possibility of losing a life, this could help us there. Then comes, as I said, on IoT. AI is, again, I'm comparing with the mind. The next comes robotic process automation. So the brain tells you, the guys, you have to lift your hand, move this, go this. Same concept comes into the business world also. In procurement also we are using it around. Logistic also we are using around RPA. Many people are using RPA quite a lot. Some of the purchase orders are going seamlessly. Whenever it comes to the minimum level, so AI tells guys, go ahead, place an order. Suppose if I've got a stock of 40, now it has come to 20 and 20 is my minimum level, it automatically pushes another PO. So that is the way robotic process automation. So it is basically, if I summarize it, it is my digital assistant. Like you have today's and many people call you up and you have to answer everyone. You have what? BOT. So BOT is also your virtual assistant. So that is the way we are calling more of an RPA. So when we talk of the use cases, location management system, when the goods are connected, I know the location. I can track them. I can find where the warehousing, where exactly they are. I can do the predictive analysis also if I add something more. But if I use the blockchain, I think it makes it much more reliable and more transparent. Today, what is happening around, let's say my medical supplies are coming from X country to Y country. On the way, it was supposed to maintain a temperature of 6 degrees, humidity of 80 degrees. Now, on the way, things have changed. Information is stored in the database, but somebody plays with the database. But once you use the blockchain, IoT is wonderful. But again, the information goes to a central database. In blockchain, it goes decentralized. And that means nobody can hamper with it. Then we're talking of self-driving vehicles. Self-driving vehicles, I'm talking, let's say, for the warehousing also. Handling equipment also. Handling forklift also. And obviously on the road, which I know is still a long way, drone-based deliveries. So within the organization, if I'm pushing up the material from one point to another point, the drone could be used around. Even for inventory management, I remember one case came long back. It used to take one of the top company of e-commerce company from one end to another end. Auditing used to take 24 hours, 24 days around. And then with the help of drone, they could do in 24 hours. So that's the way the advantage is there around. Then comes adding up the tags, sensors. So if you can, all these things are important. Look at this example. The shipment is going, the temperature is there, humidity is there, 70%, 39%, 46%. Now this is all possible through the sensors. So these sensors are checking the temperature and humidity. Then IoT is already connected. The information is going to the data bank. And the data bank is centralized. And if you can analyze it, then you can make your AI accordingly. But if you are having a doubt on the data bank, then you can go with the blockchain. So that's the beauty of it, and we get connected. So here again, it's the same example around tracking the data. You can imagine each shipment, whether by truck, whether by sea, whether by any modes, all information are being collected. I think this is very crucial now. Traditionally, if you look around, our supply chain is very simple, straight line. Logistics is also like that. No difference. So if I remove the word production in this, supply, from supplier the goods are going to, the raw material is going to the production. I've got a work in progress, again part of logistics. So then production, then distribution, then customer. So customer does not know what is happening on the supplier. The customer has placed an order for a generator. Let's say the supplier has gone on strike. Customer doesn't know it. The guy knows I'll get my goods in 7 days. No, but this one, if I connect them with a tower, if I have a tower means not the physical tower means a computerized system which connects all of them. So every information is available with everyone. Look at our own Facebook, we are all connected, a group is connected. So same way I connect all the concerned people that you could call as a tower. And the tower, if it is given AI, artificial intelligence, it can analyze and give you the information what next step to take. So this is how there's a tower concept where they're all connected in a circular form. Every information, customer knows, supplier knows, production people know, distribution. So that's the way you could call supply chain control tower. If you want to connect only the logistic concerns around, you could call logistic tower. So the word tower means I'm connecting all of them in terms of information. So if you look at the traditional one, the straight line approach, so you are difficult in getting the right data in a timely fashion. And challenges when using available data to make smart decisions. You can't make a smart decision because you are not still sure, and you get to know in a short time. Later, last silos mentalities. Obviously, when we move in a straight line approach, it becomes a silo mentality. And then difficult to plan. If I have to plan the goods around, my goods are, let's say transportation, I'm a transportation company, I'm sending my trucks, it is going half full. I'm not sure whether I'll be able to fill on the way. And when the truck will come back, whether I will have a load or not. So naturally, this pushes the price up. But if all the information is coming to me from the other side and from where the goods are leaving, on the way, what I'm going to pick it up, I can plan much better. Because ultimately, my target is my truck or my shipment, whatever is there on, should be full truckload. I should be able to utilize my assets fully. If I'm not able to use fully, that means ultimately my price will be higher. So there's an inefficiency that way. The cost will be inefficient. Coming back to this one again, digital logistics supply chain, it adds transparency. By now you understood that if you look at the example of ship, communications, all information is available to each one. Then we're also looking at collaboration part. When information is shared among all the concerned players, naturally it adds collaboration. We all become partners. But if you're in a silo, there's no collaboration. Left hand doesn't know what the right, but if we all work together, then we join hands together. There's a flexibility. If I know the customer information, time, minute to minute, I can plan better. My demand planning is much better. Responsiveness, I can respond equally quickly. So this is how the tower, if you look around the control towers, is connecting all the information centralized place. And everybody, if you are in the chain, knows what is happening around. If there's a strike somewhere, the shipment has been delayed for some reasons, everyone can plan, guys, okay, shipment is delayed, so I should take this action around. Three pillars of the control towers is obviously the process, the people, technology. Keep in mind, people. Behind everything. You might be having artificial intelligence, you might be having robotic process, but who are the people? People are the main thing. So you need to train your people to match up with the needs around. This is the shows of framework. So framework is nothing but how do we integrate different activities. Because you might be having 24 warehouses, you might be having many systems. All that system has to speak to each other. So this is where we try to connect around, whether it's in warehousing management system, ERPs, other systems, and there are 3 ERP systems around, 3 WMS systems around. How do I connect? So at the end of the day, I have one control tower which gets all the data from everywhere. So this is where the integration comes. If I say logistic 4, somebody says mine is a smart logistics, I look at 5 points around. First thing is end-to-end visibility. From the source, origin source to the user source. Does everybody knows the latest thing? Visibility part, transparency part. That's the first requirement. Sir. Smart utilities around. You may have smart containers, smart pallets, which can give you all information in terms of temperatures, humidities, whatever you want to talk about. Locations, IoT adoptions, and integration. That is very crucial because you might be having, if you're a global company, MNC company, you might be having different systems. But then you want to connect them to take a centralized decision. And better living through analytics. If you are able to analyze systematically on real-time basis, your demand forecast will be much better. And if the demand forecast is better, your wastage will be better. So in short, you'll have better living, better quality. Look at this chain. The goods are moving, I'm talking about the global chain now here, starting from one country, sending the shipment to another place, getting custom clearance, going to another production, then going to the distributors, going to the retailer, going to the customer. At every stage, we are creating so many documents. Now, these documents don't speak to each other. So when you go to the customer, say, customer asks the same documents back to you. If custom is also part of the chain, every information they have it. So this is what we're trying to do is integrate. If you're talking of a global logistic chain, or we're talking of the local one, all need to be integrated. Now, what basically is, I would say the catalyst for all this is people, people, people. In the past, it was always thought in a very simple way. Transportation, logistic is nothing but move from A to B, from point A to point B. Nobody cared about the cost part of it. If it taken 2 days, can I cut down from 2 days to 1 day? Something were taken as granted. Now I think if you want to be really 7 hours, 7 rights around, right time, right place, one has to become digital. Right supplier, right price. If you talk about all those 7 hours, the 7 rights, you have to get on digital. Now the question comes the transformation. Transformation, now we all understood digitalization. Why transform? It adds agility and responsiveness. If my demand of the customer goes up and down, last minute customer says, sorry guys, nobody's buying these goods. Can we cut down? I'm not going to buy. So that I can respond well. So there's increased agilities around. Risks are reduced. Margins are better. Improved product values around. And last is enterprise growth. So if there's a reason, I would say that there's a need to get transformed around. But the transformation, the challenges which are happening around, it is not about the technology. We did the study on this part around. Technology could be only 25–30%. People could buy the technology. If you have funds, you'll buy it. The major change happen is the management part. Are they ready for it? Organization of cycles around, staff itself, the people itself. I think they are becoming the more important. So until you train the people around, it's not easy. I remember 2006 when I implemented ERP in 200 country offices around on the procurement and supply chain. The major obstacle was people. People have to be trained. So you have to see around anything you want to bring today or tomorrow, IoT, AI, RPAs, people factors. The people have to be trained for that. Organization processes have to be changed. And the management also has to support it. So if you look around with transformation, what do we expect around? Today you get very manual data gathering. Sometimes you get through the spreadsheet, very common. But if you get into this transformation stage, it'll be real time. So no spreadsheet will be real time. Manual collaboration, now today we call each other's, guys, let's sit down together and work out. There will be digital collaboration because everybody has the same data. They're accessing the same information. Manual what if scenarios, then try to do today is, okay guys, if this does not happen, I will do this. If this happens, I will do this. I'll cut down the production. But then here's an automatic simulation. The system now simulates it and gives you this. System does not take the final decision. Basically, humans take the decision, but this cut down the cycle time of simulation. Planning, decision making, continuous event driven decision making around. The key benefits, I think we have already discussed quite a lot about it. When we're talking of digitalization, certainly the difficult areas are demand forecast. It's a tough job, one has to do it very well. Inventory planning is those, again, part of logistics, very high. Then the next one is obviously the network and routing part. I want to route them in the best route. Transport management, very high. You can imagine around in the logistic, all these relates to logistics side, freight forwarding, transport and logistic procurement part. So it's a major challenge. This is a very good example where the blockchain was used for digitalization. And Walmart has already implemented it. Let's say we're talking about the mangoes. From which tree the mangoes came, you can track and trace that even. When it was sent to the packing place, transportations, border crossing, the whole chain up to the end, starting from the tree, from the source even. So you can label each and every product from where they came. If something is bad, I can track and trace from which country it came, from which location it came. That's the beauty of it. I'm not saying that we have to overdo it, but some items, particularly the pharma item. Anyone who's dealing with the pharma companies, I think it's a must, particularly if you need an FDA approvals, they expect more and more details nowadays. Tomorrow's paradigm of logistics, again, smart logistics, you may call. Data is the first thing, data collection. How do I treat the data around? Logistic control tower, as we talked about the supply chain control tower, same way control tower. All players connected through one central system. Augmented reality. I have to augment my reality part around. That's the way to look around. Then we have the next one is the new methods of physical transportation, driverless vehicles. I mean, on the road, I'm not seeing much looking at our country's population, but at least in the warehouses, it could be thought around, particularly which are unsafe places around. Then we're talking about drones within the organizations. Then digital platforms. And lastly, but not the least, is again, new production method, which is 3D printing. So that's the concept. This is a beautiful roadmap. And short of time, I may not, it has come from Unity, they have developed it. It shows you where the warehousing is going to land at the end of the day. The way it shows, after we develop a lot, possibly we won't need a warehouse. So it shows different concepts around where we are moving. So we are still in the very beginning stage. If you look around logistics, where it is going to be next 10 or 15 or 20 years, it gives a broad ideas around where this is landing up at the end of the day. So those of you who want to see more about it, please have a look at it. So this gives a wonderful ideas. Challenges which we have today. Obviously, the biggest challenge is shadow IT and information service. We have different systems, different places, and they don't speak to each other. The question comes of integration. Breaking free from the past-oriented planning. The old system of planning we have to get out. Last but not the least is ditching the spreadsheet. I've seen many big companies around, still they depend on the spreadsheets. So I think there's a need to move from spreadsheet to real-time data and making final decisions. Well, friend, with this, I want to thank you